All right, so let's take a look at an example we got here. It might be the case that we need to solve these inequalities. So take a look at this one right here. This is an AND statement. AND statements are generally written like this. Instead of saying, let's see here, instead of saying x plus 3 is less than 5 and x plus 3 is greater than -1. Instead of doing that, it might be given to you as a compound inequality like this. That's no big deal, as long as you know how to work it. So that's what this example is here for anyway. All right. Again, our goal is to get x alone, the variable alone, and all we got to do really is we've been talking about lollipops in our class, but this just helps us make sure that we're doing all the work where it needs to be done. If we want to get x alone here, what do we have to do? We're going to have to subtract this constant off of, this is going to be a little different, but all three sides, because we want to be fair and equal. Because remember, we're really solving two inequalities here. Alright, so let's do 3 minus 3. That's going to be 0. Leaves us with x in the center. Let's bring down my inequality signs. Make sure they're brought down correctly. 5 minus 3 is 2, and -1 minus 3 is -4. Alright, so there we go. That's solving an inequality. You might have more steps, like distributing, combining like terms, and basically that might actually be it. But basically getting that variable alone might take more than one step. But then you're left with this. And again, if you have compound inequality written like this, where there's a variable in the middle and two inequality signs left and right, this is what we call an AND statement. And refer back to our first page, an AND statement looks like this, where the solutions go in between the two boundary lines, right? Again, another example is this right here. That's what ours kind of looks like. And the boundaries go in between. Our solutions are in between the two boundaries. Let's jump back up to our example here. All right, so let's start by graphing. Let's get a number line up in here. You don't have to do anything too fancy. Get a number line in. And let's write down the two numbers that are most important. Take a guess at what those are. It's going to be -4 and a +2. Next thing I would do is start putting some circles on here, whether they're open or closed circles. Depends on whether they are included. You can tell here this is just the less than sign, or x is greater, but no equal to, so that's going to be an open circle. Over here on the right, same thing. X is less than but not equal to, so it gets an open circle. And two ways you can go about the next step. It's an AND statement, so you should know that all of the solutions are going to be in between. But just to make sure, let's go back through there and look at one of these at a time. Look at this. This is x is less than 2, and x is something to -4, and it looks like x is bigger over here, so I'm going to keep x bigger. X is greater than a -4, and let's graph both of those at the same time, but remember only to graph where they'll overlap. So let's take a look at our first one right here. X is less than 2. Well, that means I go to 2, and that's going to be shaded to the left, but I'm going to stop at that boundary because AND statements are within the boundaries. And then for x is greater than -4, you go to -4, and because it's greater than, you're going to shade to the right, where all the bigger numbers would be. And there we go. That's it. That's how you graph an AND statement. Let's take a look at another example here. You should go ahead and pause the video and try this one. I mean it, like right now. Hit the pause button and copy this down and try it out yourself and see if you can get it right. Alright, so you should have paused the video and give this one a shot. I'm going to go about it the way I would. I'm going to get my lollipops in here so that I make sure that I am fair and equal to all the sides here. I'm going to identify my parts even here. Let's choose a different color for that. The variable that I want to get alone is y. 2 is the coefficient, and -2 is the constant. So let's get rid of that constant first by adding 2 and being fair and equal to all these sides here. -6 plus 2 is a -4. Is less than. This will be 0, so I'm just going to bring down the 2y. And then less than sign, 4 plus 2 is 6. I am still trying to get my variable alone, still trying to get y alone, and I have a coefficient. The way that we get rid of coefficients is by dividing. So let's divide all three sides by 2. All right, it's going to cancel out these 2's. I'm going to bring down the inequality signs right now. Keep in mind that if you do multiply or divide all these sides by negative, that you will still need to flip the inequality signs, but we divided by positive, so we're not going to do anything there. Negative 4 divided by 2 is a negative 2. 6 divided by 2 is 3. And bring down that y. Now that y is alone, we should be able to graph it. If you haven't tried graphing it yet, try doing that yourself right now and pause the video. You should get something like this with negative 2 and a 3. We should also have open circle on negative 2 because it doesn't have the equal to sign here. An open circle on 3 because it doesn't have an equal to sign. And an and statement always goes in between, but we're gonna double check that just in case. We have right here, we have y is less than 3 and it's an and statement, so, and the other one is going to be y is greater than a negative 2. Not sure how I got greater than. Take a look at this. Which one's bigger? Is y bigger or is it smaller? Well, y is bigger, so we're going to keep y is bigger, which is y is greater. And you can look at both of those. Y is less than 3 means open circle and to the left. And y is greater than 2 means negative 2, sorry, is open circle on negative 2 and to the right because it's greater. All right, so we definitely did graph that right. Interval notation would be pretty simple. Read the graph from left to right and go negative 2, comma, 3. And then they both get parentheses because they're both not solutions, but any number between those two is a solution. All right, so I'm going to do this one with you guys, but try to follow along. Even pause the video if you feel like you're confident enough to do this one. We're going to do this one together, though. This one's an or statement, and if you remember correctly, I've got to select the pen here. On a number line, that means we will be going some number here, and we're going to be graphing out. That's an or statement. All right, so that's what we're going to be looking for in the end, and we're going to see if that all works out. For or statements, you're just going to solve them separately. I'm going to solve this left-hand side one, and then I'll come over here and work on the right-hand side. So 4m minus 5 is less than negative 9. I want to get m alone. There's my coefficient. There's my constant. We are going to add 5 to both sides to get rid of the constant. Negative 5 plus 5 is 0. Let's bring down the 4m. The less than sign. Negative 9 plus 5 is a negative 4. And then lastly, we're still trying to get that m alone. We need to get rid of the coefficient, and the way that we get rid of coefficients is divide by 4. 4's will cancel and leave me with m is less than, negative 4 divided by 4 is negative 1. That's part of it. Okay, let's go over to the right-hand side now and solve for m. There's m, there's my coefficient, there's my constant, and my lollipop, just to make sure that I'm fair and equal to all the sides. Start by adding 5 to get rid of the constant. Negative 5 plus 5 is 0. Bring down 4m. Bring down the greater than sign. Bring down 7 plus 5, which is 12. And lastly, let's get rid of that coefficient by dividing by 4. 4 is canceling with m is greater than 12 divided by 4 is 3. And I like to write this back in the center just so that I remember that this is an or statement, right? It's an or statement. All right, let's get our number line down. This will be the graph for it. The two numbers that are most important are negative 1, the smallest number, and the biggest number that's important to us is 3. Let's go talk about open or closed circles on those. M is less than negative 1 means open circle. M is greater than 3 means a open circle as well, no equal to sign. And then where we shade depends on the sign. So let's go back up here. M is less than a negative 1 means to go to the left toward negative infinity. m is greater than 3 means to go to the right of 3 toward positive infinity. And you might do yourself a favor and actually write that down, negative infinity and positive infinity, because you might be asked to write this in interval notation. But there's our graph. Interval notation means to read it from left to right, so negative infinity, comma, negative 1. We have parentheses on infinity because you can never contain that as a solution. This is an open circle, so another parentheses. Over here is a 3, comma, to infinity, least to greatest there still. Parentheses on infinity because you can never contain that as a solution, and parentheses on 3 because this is not a filled-in circle and it's open. And because this is an OR statement, you might have to remember this, but go back to that the second slide there. An OR statement is represented by the U symbol for union. So right in between our interval notation, we're going to write a U. And guys, that's it. I'm going to do one more example, but you guys should try it first. This is on you. Go ahead and pause the video, and you should right now hit the pause button and try this one out for yourself, and then hit play again to see if you got it right. So here we go. Let's get x alone here. No coefficient that I need to worry about. I do have a constant to get rid of those, so subtract 3. That's going to be 0. Leaves me with x is less than negative 7. That one's done. Or, same thing here, trying to get x alone, so I subtract 3 to get rid of the constant. X is greater than or equal to 4 minus 3 is actually 1. Let's get the number line down here for our graph. First number is negative 7. Second number is positive 1. Over here, x is less than a negative 7 means an open circle. And to the left, because it's less than. And then over here, x is greater than or equal to 1 means a closed circle this time. And greater than means to go to the right toward positive infinity. Okay, so remember this arrow over here means to go to negative infinity. This arrow over here means to go to positive infinity. That's the graph. Let's do interval notation now, reading from left to right. So negative infinity, negative 7. These both get parentheses. Infinity always, because you can never contain infinity. Negative 7 because it has that open circle. This is an OR statement, so U. And then 1, comma, infinity. 1 this time gets a bracket, though, because 1 is a solution. It is a solution as a filled-in circle here. Has that equal to sign. And then infinity always gets parentheses. And y'all, that is compound inequalities. Again, there might be more steps in solving. You should be able to solve inequalities by now, so we'll get more practice with that if you're struggling. You also need to be able to graph it and give me interval notation for it. All right. That's our focus for today, and that's our last slide. So remember, finish the activity that's going to be followed here on my Canvas page. And again, guys, remember to ask questions if you need help. Feel free to work together even with somebody, but make sure you guys are getting the understanding. That's most important, okay? Have a good one, guys.